Welcome everyone, I am Mr. Ish. Thank you for joining me for this video where we are solving this question. We have here a non-homogeneous second order differential equation and boundary values have been provided. When you solve a differential equation, you arrive at a general solution, but when you incorporate those boundary values, you can come up with a specific solution. When you look over here, you have a second order representation, d square x or dt square is equal to 3 sine t minus 4x. At time t equals 0, you have x equals 0. At time t equals pi over 2, you have a first order dx over dt which is equal to 1. Look at this item over here, and you're seeing an x and a t, and those will be your variables. X here will be your dependent variable, and t in terms of time will be your independent variable. This right here question coming from an engineering application. We're not talking about engineering, we're just using our calculus techniques to solve it. If in case this were applicable to you, it would be very relevant to watch this video. You know, when you're looking at this, you can rewrite everything as this: x double prime is equal to 3 sine t minus 4x. Now you see it, x's and t's are your variables, and let's start solving it out. That right here is my second order non-homogeneous differential equation with the variables x's and t's. You'll come out here with a general solution. We'll convert the general solution to a specific solution using those boundary items. The complementary function will come from right here. You know, when you look at this type of representation, you're coming here with a certain bunch of items. You can say your items will be this: x is equal to e exponent rt. In a generalized representation where you're looking at x's and y's, this right here would be synonymous with you saying y is equal to e exponent rx. But because our variables are x's and t's, you see how the difference is? You have to keep that in mind. X is equal to e exponent rt. The first order derivative is equal to r e exponent rt, and the second order, you know, will be r squared e to the rt. Now look, I'm seeing here a second order and a zero order, so this item will come in and this item will come in, and let's bring them in. We'll bring them in here for a complementary function determination. I have here an r squared e to the power of rt plus 4 e to the rt is equal to 0. You always make it 0 because you're using your homogeneous techniques. If you were to isolate the exponential and take it on the other side, it would zero out. You can cross them out. You are looking here at r squared plus 4 is equal to 0. Solve for r. R here is equal to the square root of minus 4, which is plus and minus 2i, which you can say as 0 plus and minus 2i, which you know is a plus and minus bi. Complex conjugates. You know, when you're looking at complex conjugates, your basic template here, I'm going back to x's and y's, is this: e exponent ax. Then you have an arbitrary constant capital A cosine bx. You see these lowercases a and b's, those are this. The capitalized items are your constants, then b sine and then lowercase bx. This right here is your representation for your complementary function when your homogeneous equation part gives you complex conjugates. Now we have to bring these values in. A is equal to 0, b is equal to 2, and we plug away. If a is equal to 0, this e exponent 0 is a 1. This goes away, so I'm erasing it out. You don't need it because e exponent 0 is a 1. There's no need to write it. Our complementary function, when you bring in the items here, will be what? It will be x is equal to, now think back to your variables or x's and t's. X is equal to a cosine 2t plus b sine 2t, and that right there is it. We have our complementary function determined. We have our boundary functions over there, our boundary values in the top right corner. Now we have to worry about our particular integral, which will come from right over here. When you're looking at a particular integral which is trigonometric, you know you're really looking at y equals something, but since our variables are x's and t's, we'll say x here is equal to c cosine t plus d sine t. This right here is the basic template which will give you your particular integral for a trigonometric function. Now you have to look at the first order derivative, which is what? The derivative of this. You'll have a minus c sine t plus d cosine t. Then the second order derivative, bring the derivative of this item right here. You'll have here a minus c cosine t minus d sine t. You would bring all of these items into this, but you're seeing that you have a second order and a zero order. This will come into play, this will come into play, this right here will not come into play because you're not seeing this item that you can substitute. When you substitute these two items here, what do you have? You'll have here a minus c cosine t minus d sine t, then plus 4x, 4 times all of this, plus 4c cosine t, and then plus 4d sine t is equal to what? Exactly what you see here, 3 sine t. What we are doing over here is developing our systems of linear equations, and we will. I'm erasing this because we don't need to see this anymore. Isolate your cosine components. I am looking here at a cosine t component which involves here a minus c, and I have a plus 4c. I have a sine t component which involves a minus d and a plus 4d. My cosine component has no corresponding term on the other side of the equal sign. It's equal to 0, but my sine has a component is equal to 3 sine t. Now, if you just look at these items and throughout the trigonometric functions, you have systems of equations which are what? You have a 3c is equal to 0 and you have a 3d is equal to 3. Now solve for them. You know when you're solving from this, what you're saying, c is equal to 0 and d is equal to a 1. What do we do with this two values? You're going to bring them right here into your template, which I've erased, but I'm going to bring it back for you. And you know what that template was. I'm erasing this. I'm bringing back the basic template, which was this. X is equal to c cosine t plus d sine t. That's what we're bringing the c and d into. X here is equal to, well, you have a sine t. Because c is equal to 0, it zeros is out. D is equal to 1, you retain x is equal to sine t. This right here is my particular integral, which will be added to our general solution. You don't need to see anything else over here, so let's erase it and bring out our general solution. Then we look here at these boundary values. Our general solution for this differential equation will be this. General solution is equal to, I have here x is equal to a cosine 2t plus b sine 2t. This right here is my complementary function plus my particular integral sine t. Now we can erase some of this clutter because we need space to deal with those boundary functions. We have those boundary values at time t equals 0, x equals 0. This right here is x and t's. This right here is your zero order function, meaning it's zero order derivative. It's your basic function. You will utilize these set of values first. At time t equals 0, x is equal to 0, so plug them away. At time t equals 0, x was equal to 0 as you're seeing, then you have a cosine 2 times 0 because time t is equal to 0, which is a 0, plus b sine 2 times 0, which is a 0, plus sine of 0. You know sine of 0 is always a 0, these go away. But cosine of 0 is not equal to a 0, it's equal to a 1. I'm looking at 0 is equal to a. So that's what it is. Now you've determined 0 is equal to a. We've determined the value of this arbitrary constant. Let's look here at our second set of items right here. And that involves a derivative. If x is equal to that, then you have to do the derivative of that. What's the derivative of this statement? dx over dt is equal to the derivative of all of this. You will have here the derivative of this coming, which will be minus 2a sine 2t. You're doing the chain rule, but you're doing it in your head. You're running this through the chain rule, and likewise here you'll have a plus 2b cosine 2t, and the derivative of sine t here is a cosine t. Now in this statement right here, you plug in your other values. You know at time t is equal to pi over 2, the derivative is equal to 1, so this right here is equal to 1. Let's bring it in. 1 is equal to minus 2a sine 2t, but I know a is equal to 0. This will go away, so I have a 0, plus 2b cosine 2t. At time t is equal to pi over 2, I'm doing 2b cosine pi over 2 times 2. 2 times pi over 2 is a pi, plus cosine of pi over 2. Cosine of pi over 2 is 0. This goes away. Now what we're doing in essence is we've determined the value of a. We're determining the value of b. I have 1 is equal to, this is equal to 0, that's equal to 0. Cosine of pi is a what? It's a minus 1. I have a minus 2b. Therefore b is equal to minus 1 over 2. I've determined b is equal to minus 1 over 2 and a is equal to 0. I determined one constant using the top values. I determined the second constant value using the bottom values. What do we do with these? We come back here into our general solution, which is right over here, and we plug away with a and b and we see what happens. We've determined a is equal to 0. Let's put that here. A is equal to 0 and we've determined b is equal to minus 1 over 2. We'll come here into our basic general solution. I'll erase this part over here, then I'll give you your final answer. which is what will be when you have solved this differential equation using those boundary values. Look back here at your general solution. X was equal to what, and plug your a and b. X here is equal to a, which is a 0. This zeroes out. I have a b which is equal to minus 1 over 2. So let's bring that at minus 1 over 2 sine 2t plus sine t. There's no constant here. This came from your particular integral, so this right here is your answer, but you can write it in a better way. X here is equal to sine t, the positive term first, minus 1 over 2 sine 2t. This here is your answer. If someone were to give you this question on the exam with those boundary values and they ask you to solve it, then you are presenting them here a good answer, an exact answer. It's not a general solution anymore. It's your exact solution, and that right there should be a correct answer. That's it for this video. Thank you for watching.